Hi, good day. Welcome back to our class in chemistry. Today, we're going to continue our discussion on stoichiometry. Last time, we discussed on the stoichiometric relations based on the chemical formula of a compound. Today, we're going to discuss the stoichiometric relation based on the chemical balance reaction. The stoichiometric calculations, especially those which are based on the balanced chemical reaction, is important. This is because in the manufacturing processes, the cost of the reactants and the value of the products are critical. To start with the stoichiometric relation based on chemical reaction, let us have the gram and mole relations. In calculating the gram and mole relation, it is important to balance first the chemical reaction, because from the balanced chemical reaction, we can get the proportion of the number of moles of the reactants and the number of moles of the products. Likewise, we can also get the number of grams of the reactants and the number of grams of the products. For example, if we have the chemical reaction between magnesium chloride and sodium carbonate, we can form the products sodium chloride and magnesium carbonate. If you're going to look at the chemical reaction, it is not balanced. Therefore, to balance the chemical reaction, we are going to place 2 as a coefficient to the product sodium chloride. So the balanced chemical reaction now would look like 1 mole of the magnesium chloride plus 1 mole of the sodium carbonate will produce 2 moles of the sodium chloride and 1 mole of the magnesium carbonate. Now, to establish the mole relation, we are going to use the actual number of moles used in the chemical reaction. With those numbers used as coefficients in balancing the chemical reaction, they are to be used in establishing the mole relation. Therefore, in this particular reaction, the mole relations are 1 mole of magnesium chloride is to 1 mole of sodium carbonate is to 2 moles of sodium chloride is to 1 mole of magnesium carbonate. So that is the mole relation we can establish in that particular reaction, or in this particular reaction. Now, to establish the gram relation, we're going to use the molecular mass of these reactants and the products, considering also the coefficients used in balancing the reaction. So in this case, the molecular mass of magnesium chloride is 94 grams. The molecular mass of sodium carbonate is 106 grams. The molecular mass of sodium chloride in the product, since it is multiplied by 2, sodium chloride is having only a molecular mass of 58, and when you multiply that by 2, it becomes 116 grams. And for the molecular mass of magnesium carbonate, it is 84 grams. So that is the gram relation. The gram relations, therefore, are 94 grams of magnesium chloride is to 106 grams of sodium carbonate is to 116 grams of sodium chloride is to 84 grams of magnesium carbonate. So that is how to establish a gram and mole relation. Again, how are you going to establish the gram and mole relation? It is important to balance the chemical reaction first, because from this balanced chemical reaction, you can get the number of moles and the number of grams. Another stoichiometric relation which is based on the balanced chemical reaction, is that of finding the limiting reagent. By the way, the limiting reagent is that reagent or reactant which is used up first in the chemical reaction. This reactant or reagent tells us or determines the theoretical yield. There are steps to follow on how to determine the limiting reagent. First, we are going to balance the chemical reaction. Second, establish the mole and the gram relation, as I have just discussed a while ago. Third, get the number of moles of the desired product. And fourth, choose that reactant or reagent which gives the least or lesser number of moles of the desired product. By the way, in all chemical reactions, there is the limiting reagent and there is also the excess reagent. Now, this excess reagent is that reagent which is of course used in excess, meaning there are some amount of this reagent which is not used in the chemical reaction. And this reagent does not determine the theoretical yield. For example, in determining the limiting reagent and the excess reagent. And the chemical reaction, which is iron plus oxygen, forms the product ferric oxide. Now, you have the reaction, therefore, which is Fe plus O2 equals Fe2O3. Now, we said that in computing for the limiting reagent, I said that it is important to balance the chemical reaction. So, to balance the chemical reaction, we have 4 moles of iron reacts with 3 moles of oxygen in order to form 2 moles of the ferric oxide. The second step is establish the mole and gram relation. Now, based on the balanced chemical reaction, the mole relations are 4 moles of iron is to 3 moles of oxygen is to 2 moles of ferric oxide. Then establish also the gram relation. The gram relations are 224 grams of iron is to 96 grams of oxygen is to 320 grams of ferric oxide. Now, from these gram relations, we can solve for the number of moles of the desired product. Our desired product here is the ferric oxide. Now, step 3 says that you are going to get the number of moles of the desired product. So, based on the reactant iron, it is given in the problem that 15 grams of iron reacts with 20 grams of oxygen. Now, to compute for the number of moles of the desired product, which is ferric oxide, based on the amount of the reactant iron, since we use 15 grams of the iron, multiply this by the mole relation over the gram relation that we have set or established in step 2. So the equation would be number of moles of ferric oxide, which is our desired product, equals 2 moles of ferric oxide is to 224 grams of iron. Canceling out the gram unit, then we can get the result. Number of moles of ferric oxide is 0.134 moles. Now, computing again the number of moles of ferric oxide based on the reactant oxygen. Now, we know that in the problem we are given that 20 grams of oxygen is used in the chemical reaction. So, computing for the number of moles of the desired product, which is ferric oxide, it is number of moles of ferric oxide equals 20 grams of oxygen times 2 moles of the ferric oxide divided by 96 grams of oxygen. So canceling out the unit grams, so you have the result 0.417 moles of ferric oxide. Step 4 says that choose which of the reactants gave or yielded the lesser number of moles of the desired product. In this case, the iron gave the lesser number of moles of the desired product. Therefore, we can say that the limiting reagent is the iron. And automatically, the accessory agent is the oxygen. Another application of the stoichiometric relation based on chemical reaction is that of finding the theoretical yield. Now, the theoretical yield is that amount of the desired product which can be obtained based on the limiting reagent. In that particular problem that we have just discussed, that is finding the limiting reagent and the accessory agent, given that there is 15 grams of iron reacting with 20 grams of oxygen, and we have computed that the limiting reagent is that of the iron. Since we have already computed that the number of moles obtained of the desired product, which is the ferric oxide, is 0.134 based on the reactant iron. So this amount in terms of moles, which is 0.134, will be converted into number of grams by multiplying this number of moles of the desired product by the gram and mole relation that we have established in step 2. So that in computing the theoretical yield, this is number of grams theoretical yield equals 0.134 moles ferric oxide times 320 grams of ferric oxide divided by 2 moles of ferric oxide. So the result is 21.44 grams of ferric oxide. So that is the number of grams of the desired product, which we call it as our theoretical yield. Now, another application of the stoichiometric relation is the finding of the percent yield. In finding the percent yield, we are going to compare the actual yield to that of the theoretical yield. Usually, in the manufacturing process, the actual yield is lesser than that of the theoretical yield. Going back to that problem which we have just discussed on the reaction between iron and oxygen, we have computed that the theoretical yield is 21.44 grams of ferric oxide. Suppose we are going to add a data to the problem that the actual yield is 19.5 grams of ferric oxide. Now, how is this actual yield related to the theoretical yield? The formula in getting the percent yield is percent yield equals the actual yield divided by the theoretical yield times 100. Substituting the values of this actual yield and the theoretical yield to the formula, the equation will look like this. Percent yield equals 19.5 grams of ferric oxide divided by 21.44 grams of ferric oxide times 100. Percent yield equals 90.95%. So those are the applications and uses of the stoichiometric relation based on the balanced chemical reaction. I will be giving you an exercise about this, and please take note that on Friday I will give a quiz about the stoichiometric relations based on the chemical formula of the compound and the stoichiometric relations based on the balanced chemical reaction. That would be all for today. This is your teacher, Professor Nisitas Ruiz of Holy Name University.